Okay, so we need to start talking about details, right? Details, the devil's in the details every single time. And it seems like that's what gets us when we go into the chromatography world. There's just so many choices and so many things to choose from that I begin to easily get overwhelmed when it concerns the stationary phase and the mobile phase and how it interacts and everything else in between. So we're going to take it simple and we're just going to kind of talk about the basic TLC and kind of tell you the do's and the don'ts of developing plates. All right, so a TLC plate. Well, first, the thing that you have to keep in mind is that we do call these things plates, right? TLC plate. However, the plates can be glass, or they can be plastic, or it can also just be paper. Doesn't really matter. Okay, so those are the different forms that the plates will come in. The paper, of course, is the cheapest. So this is just really like a piece of coffee filter, if you want to think of it that way. That's all that it is. And the coffee filter will do something very similar that these other more expensive plates will do. It might not be the best stationary phase or the best material to develop your sample on, which is why it's not one of the most common, but paper is a possibility for you to use. The plastic plates are going to be a little more expensive. All right. The thing with the plastic plates is that these things are very flexible and they can bend and not break on you. And some people like that, right? They like the flexibility. They don't like the rigidness that the glass can give, and they feel more comfortable using them. Well, they're also cheaper because of that. It's a cheaper material that they can make the plate out of, and your separation is going to be basically similar to a glass plate. There's no difference there either. The problem here is that because they're flexible, that's also the drawback. So what you have to watch out for, and I'm going to put it in exclamation marks here, what you have to watch out for is cracking of the stationary phase, because it is a flexible back. Okay, the backing of the plate is flexible, but there's still stationary phase that's on top of that material. So if the piece of plastic bends too much, then your stationary phase is going to crack and you're going to ruin the stationary phase because of that. So that's another reason that people stay away from that material. Paper is not the ideal stationary phase. The plastic backing's cheap, but the problem is that it's flexible and it can disturb my stationary phase and really ruin my whole analysis if I put a spot of sample on it and develop it and not catch that there is a crack in the stationary phase. Remember, this is something that we talked about back in column chromatography. We said if your stationary phase cracks, then it's all over. It's ruined. You need to make sure that your stationary phase stays wet throughout the analysis of the column chromatography. Well, the same thing can be said here. That crack is in that stationary phase, but it's not due to not keeping the stationary phase wet. It's just basically due to mishandling the plate itself. All right, so the glass here, the glass is way more expensive. That's the drawback with the glass, is the cost. And then that glass, however, is very rigid. And it really protects, so I'm going to put a check mark here, it protects the stationary phase in a way from any damage that might be associated with mishandling that plate itself. All right, so I've got to give you kind of an idea of what these glass and plastic plates look like. So I'm going to I'm going to look at this slide on the side. All right, so this is going to be basically the material that the plate is made out of. So this is going to be the plastic, or this is going to be the glass. And on top of the plastic or that piece of glass, there is stationary phase that has been loaded on top of that. So I'm going to draw a layer, and it should be very even. It should not be crooked like that. But there should be a very thin layer of stationary phase on top of that piece of glass or piece of plastic. Okay? So now you can kind of see why the plastic would be a problem. The plastic will bend back here, and as it bends left or right, or as you twist it, this stationary phase is going to be damaged, and you don't want that to happen. Okay? The glass backing, though, think of it as a microscope slide. That microscope slide would be very rigid and very structured, and it's not going to damage or twist and turn the stationary phase and begin to crack it or begin to destroy it. Here's the problem, though. This side with the stationary phase is open. So that means it's open to everything. It's also open to your fingers. So if you mishandle the plate, you can actually disturb the surface yourself. Okay? So if you mishandle the plate, I'm going to say that you are going to disturb the surface with your fingers. So you can disturb it. And that is through your nasty fingertips. So we want to make sure that we do not damage the surface of the TLC plate. We want to make sure that we do not touch the surface of the TLC plate. So I'm going to put do not touch the surface of the TLC plate. And I'm going to put in parentheses here, always touch the sides. Very important. Whenever I use plastic, whenever I use glass, even whenever I use paper, I try to only handle the sides of those plates, and I allow the sides of the plates to be my point of contact. And if I'm holding the sides, I'm not disturbing the surface of anything. So I want to make sure that the way it comes out of the box is the way that it stays, because this thing has been manufactured a certain way. So don't be putting your nasty, greasy fingertips all over the surface of the TLC plate and disturbing that stationary phase, because you're contaminating the stationary phase, you're contaminating your sample, and you're ruining the stationary phase all at the same time. So keep your nasty fingers off of that TLC plate. Only touch the sides when you're doing these labs. All right? Okay, so there's a little bit of background with the plastic, a little bit of background about the glass, a little bit of background about the paper, and out of all three, the most common is the glass. That's what we see most often, and that's what we use in our laboratory too as well. And with the glass plates, I told you that these are the most expensive. They run, depending on the year, $1 to $2 per plate. So as you run your samples on the TLC plates, I want you to keep that in mind, okay? Don't be messing them up and throwing them away left and right. We want you to kind of use them with some consideration, pretend like it's your own money that you have spent, and handle these the proper way and load samples on them the proper way. Because $1 to $2 will begin to add up per plate when we have each one of you run anywhere between 8 to 10 per lab. You know, that's $20 maybe for each person. And if there's 10 or 15 people in the lab, you're looking at $200, $250, maybe $300 just in TLC plate usage for one run if nobody messes up. So please keep that in mind. Handle these with grace. Handle these with TLC, and I think that you'll be okay.